Okay, this is I think the last lecture regarding the motivation that why should we study materials, right? So from the next lecture we will go to the technical topics, that what is material, what are materials, what are their different types and their properties, their structures, and these things will be, and introduction to these things will be discussed. I told you in the last lecture that there were two big revolutions in the material world, and they actually founded the engineering, the skill of the engineering of materials. The porcelain, the English china, which made cooking pots, which made ovens, which made developed to dinner sets, and the clay was converted into a shiny white product, and that was one revolution. The other big revolution which completely changed the pace of the world we are seeing today was the wireless telecommunication. And that is why we call this age as the IT age. It was very simple that we were using wireless sets and used to carry them in very big lorries, because the vacuum cavity people used to use could not be integrated. It was Richmond in 1939 who for the first time said, or you can say proposed, that a solid state dielectric resonator can be also used for instead of that cavity. What sort of resonator and what was its role? The main thing which was required from those resonators, that, and I told you in the previous lecture, that if you want to use a small amount of sugar, make it more sweet, or make it sweeter. So when the sugar is sweeter, then you will use less amount of sugar to sweeten the tea. The same thing was here, that if you need a property from a material and 2 kg material is needed to do a job, if that property is enhanced, obviously the amount of the material required will be decreased. So the target was to increase the dielectric constant or relative permittivity of the material, and that led to smaller components. The smaller the components, the lighter the weight will be, and the size of the circuit was inversely proportional to the square root of the dielectric constant. So the higher the dielectric constant, the smaller will be the circuit size. And other issue is the tunability. That what are the main things in your cell phone? There are 3 major things in your cell phone. Number 1, it resonates at specific frequencies. This means your call cannot be interrupted in the middle. Similarly, it is tunable and selective within the required frequency range, and that is measured in terms of the quality factor. The higher the quality factor, the more chance you will have to tune into the selected frequencies. and there is a range of frequencies which are used for specific applications. For example, there is a separate range for GPS system, global positioning system. Then for cell phones, there is another one. Then for defense purposes, there is another range. So they are not mixing up and they are not compromising the communication of various frequency ranges. That was the thing. And the third important thing was that if you use the material in a low temperature region or in a high temperature region, it doesn't disrupt its functioning, because everything, this table is stable in a solid form at room temperature. This wall is solid but in room temperature. If you increase the temperature of this wall to 1500 degrees Celsius, it will be a liquid. So as a physicist, you should think in terms of bonding, in terms of atomic structure, not like a layman. So this wall can be a liquid, this wall can be a gas, and it is solid because the temperature is such that it doesn't melt it. Right? So every property is associated with a specific set of parameters. If the temperature is higher, then the case is not the same. If the temperature is lower, water freezes. They are no more liquid, they are solids. So they wanted the cell phone or the device to work equally well at higher and lower temperatures. And these three properties are called the dielectric constant, the quality factor, and the temperature coefficient of resonant frequency, TCF, temperature coefficient of resonant frequency. If you change the temperature, the resonance frequency changes. But the device needed one which doesn't change. All the people around the world started work to get these three sets, this set of properties for various materials. Some property exhibited excellent properties, but they were not stable. The sample was not strong enough to withstand its use. For example, you can have a beautiful material to make door handles, but if you pull it and it breaks down, then it is of no use. Although it is beautiful, it is comfortable. So you are looking for these three properties along with the mechanical properties so that they can withstand the usage in different environments and coming across different users. It was proposed by Richmond in 1939. And the first resonator which could be commercialized came in up to 60s. They achieved after 36 years a material with a dielectric constant of 39.8 QF and QU, loaded and unloaded. There are two terminologies used commonly for these frequencies. At 4 gigahertz and 2 ppm per degree Celsius temperature coefficient of resonant frequency. Nowadays, the benchmark of the telecommunication, wireless telecommunication industry is that the dielectric constant should be depending on the application. Sometimes you need smaller, can afford smaller values for dielectric constant, sometimes you need higher. But the general benchmark for cell phones is considered to be about up 40 to 50 or like that. The QF should be above than 10,000. and the temperature coefficient of resonant frequency should be in between -10 to +10. Sometimes the signal travels a lot in free space and its propagation inside the component is very small. For that case, you don't need very good dielectric constant. And for example, for radar and antennae you are using for telecommunication, you can have dielectric constant as low as 10 or 5. But the frequencies should be very high. And most of the silicate minerals are used to get substrates of materials with low dielectric constant and very high frequencies. The commercialization came in 80s. The first cell phone was introduced in 1985 or 83, like that. I have written it somewhere. It will come in our discussion sometimes. This means that there is a continuous run between, to close the gap, to reduce the gap between technology and physical objects. We couldn't develop flying cars. If people asked you that what science could do to the society, we didn't develop flying cars. It used to be said, but people have developed in the world flying cars as well. Individual aeroplanes are available if someone can afford. So science has done that. But what the last couple of centuries have seen, the world has transformed into smart materials. The world has become much smarter. And we used to call a university, but the present day kids are saying, I am going to uni. And people understand it. This means that the world is going smarter and smarter. They are using less. With less consumption, they are producing more. The smarter means that you wear some clothes and they change their behavior with changing temperature. In summer, you want coolness, and in cold weather, you need warmth. And the smart clothes can give you that. Right? To say it is a small word, but associated with it is a very huge structure. Can you imagine that in coming 50 years or 40 years, people will start to live in big buildings and only their clothes will be enough to live with? Because if there is no need to cool or warm your body and the clothes does that, then why not have an individual space and live there? We don't know what the coming generation are thinking to do, right? But a small invention, your cell phone was a very small invention, but it changed the world. So smarter materials can make the world much smarter. Your kids, they can change the color of their bedroom with the flick of a button, switch it on, off and change the color. Similarly, you can change the temperature if you are using electrocaloric materials. When with the electric field, the material undergoes transition and it produces energy. Obviously, energy can be converted into any form and you convert it into heat. So a flash of light can change the behavior of a material. The world is yours. The universe is yours. It is upon you whether you wish to own it or not. If you wish to own it, if you wish to claim your share in the universe, learn it and it is yours. And where to learn it? This classroom is the place. This classroom make changes. This classroom bring revolutions. This classroom develop nations. And what you learn and what can you do will be the shape of the world tomorrow. Whatever shape you want for your world, it is your mind. You decide how you want your world to be, and you can do it through knowledge. The universe is generous. I told you the story of carbon, probably in the last lecture, that carbon was 25,000 years old, and the 2010 Nobel Prize was given for graphene. This means that we have not yet discovered carbon and its property, what it has. You have 118 or even more elements today in your periodic table. You have not yet explored the oldest element, carbon. This means the world has many more things to share with you, but it is upon you. Can you do that? This is upon your mental strength, your hard work, that how much you can go into these materials and you explore it and you change everything in the world to come. And when you bring a change, the next generated world, the world emerging from on the basis of your knowledge and mind will be your world. If somebody else changes the world, you will have to live according to their wish, because it is their world. You are making a room and a person enters it and he asks you that, should I take off my shoes? You say, no, okay, come. Or you tell them in the start that if you are entering this room, take off your shoes, because you have developed that room and you are the authority there. So the world, developing a room is much easier. Developing a new world, innovation, bringing innovation, it needs a lot of hard work of centuries. Will that person allow you to dictate it? Never. You will have to live according to his or her wish, in his or her world. So, if you have a sharing contribution to the developments, then you will have a say in the world to come. But if you have no contribution, then you are living like a parasite and you should obey whatever the developers say. So this is the knowledge, this is the skill, and you can own your world through knowledge and skill. The people who can do it are called developed people, and the people who cannot do it are called underdeveloped. This classroom is the differentiator between the two. The people who learn in this classroom and apply them in their society, they are called developed. And the people who waste their time in their institutions, they are wasting the resources, they are wasting their lives, and they have no future but to live at the disposal of the hard workers. Very simple. Two brothers, one is earning, the other is not. At the evening when you reach home, the dinner should be at the wish of the earner, not of the user. You cannot dictate anyone that the food should be like this or that. It depends on those who earn it. So earn something in your universe and it will be yours. And these needs excellent institutions. In the last lecture I told you that 3 persons are most important in making nations. The first thing